Hello and welcome to your Algebra 2 notes for the year. We're going to start here with section 1-1, which is titled Expressions. And some of this is going to sound a lot like what you already learned in Algebra 1. That's why we're doing the flipped classroom here so that you can go through these notes and know exactly how long it's going to take you. So follow along on the sheet of notes that you have, and we'll go ahead and start right here. So the basis of most of algebra is this statement right here. It says, an algebraic expression is a way of representing a calculation, so we know that. And obviously we're going to be using letters to stand for numbers. Right? Those letters we know are called variables when we use them in math, and we learned that in Algebra 1. So letters to stand for numbers. And you'll have to excuse the writing. Tough to write on the iPad sometimes. All right, so if you take a look at this next statement, it says pi r squared h is the volume of a cylinder with a radius of r and a height h. What calculations are taking place, and what is the significance of being able to write this as an expression? The most obvious thing that you should notice is that being able to write it like this allows us to write it in a much more compact fashion, writing pi r squared h, as opposed to writing all of that out by saying pi times the radius squared times height. Right? So that's one of the big reasons that we like to write it like that, is that it is shorter and a lot more compact. Okay, so if we slide over to the next slide, or you can just look to the right on your notes, it says example 1, describe a method for calculating a 20% tip on a restaurant bill and use it to calculate the tip on a bill of $8.95 and a bill of $23.70. All right, so if you're following along in the textbook as well, it's mentioned that 20% is equivalent to 0.2. So one method is to multiply 8.95 times 0.2. That's one method. Another method you could do, and I'm sure a lot of you have seen this before, used this before, we know that it would be very easy to calculate 10% of $8.95. You can just slide your decimal over one place this way because you're multiplying by 0.10. So it's about 90 cents, and if that's 10%, to get 20%, we can just double that, and you get approximately $1.80. So based on what we did on this slide here, if you go down to the bottom left, where it says section 1-1 expressions, example 1b, now it says choosing the letter B to stand for the bill amount, represent your method in symbols. So using what they gave you in the textbook, you could just write 0.2 times B, or what we did, because the mental math of doing times 0.1 would be a little bit easier, you could do that multiplication first, put it in parentheses, and then write 2 out in front of it. Now, one of the things that you'll notice here is that this is going to be the key of this section, writing stuff like this, and in expression form, and really simplifying what the problem's telling you to do. All right, so the last slide on this first page of notes is very simple. It says if we give particular values to the variables, then we can find the corresponding value of the expression. So in the previous problem, we had 0.2b. If you knew what the total amount of the bill was, you plug that in for b, and that's the total of the bill, right? And we know that once you give value to it, what you're doing is you are evaluating. So you are evaluating the expression once you know a value to plug in for the variable, and then you simplify the expression from there. So we can see in this problem in example 2, it says Juan's total cost for 5 bags of chips at C dollars and 10 bottles of soda at S dollars each is given by the following. So the total cost is this expression right here. So we know this is an expression, just this part right here, because it doesn't have an equal sign. So it says if a bag of chips costs $2.99 and a bottle of soda costs $1.29, find the total cost. So we know that we are going to substitute $2.99 in for C and $1.29 in for S. So you're going to replace C with $2.99 and you're going to replace S with $1.29. When you multiply 5 times $2.99, you get $14.95, and 10 times $1.29 is $12.90, so you get a total of $27.85. All right, let's move on to the next slide over here. We'll go ahead and do one of these two, and you can see the other one in your textbook. So it says evaluate 3x minus 4y and 4x squared plus 9x plus 7y using these different values. So we know evaluate means to give value to. So for this first one right here, 3x minus 4y, we're going to replace x with 2, and we're going to replace y with negative 5. So once we do that, we're going to go ahead and follow order of operations, and we're going to do 3 times 2, which gives us 6. You can leave this as a minus right here, or you can make it plus negative, whatever is easiest for you. If I leave that as a minus sign, then I'm doing 4 times negative 5, and we know that that's going to give me negative 20. Again, you have to be very careful here with what you're doing with this subtraction sign there. So since I left it as subtraction, now it becomes 6 minus negative 20, which now I can change to 6 plus positive 20, and that's going to give me 26 as my answer for part A. For part B, I'm going to do this problem right here. So 4x squared plus 9x plus 7y, but now I'm going to use these values. So I used the values in A for the first problem. I'm going to use these. So I'm going to write 4x squared plus 9x plus 7y, and I'm going to go ahead and replace. So I have 4 times the quantity negative 2 squared plus 9 times negative 2, and then plus 7, and I'm using 3 because this one was y and not x. Remember, when you do this part of the problem right here, you have to do negative 2 squared first, which will give you positive 4, then times 4, which is 16, plus 9 times negative 2 is negative 18, and 7 times 3 is 21. Now that they are all addition, at this point of the problem, I can add any of these in any order that I want. I'm just going to work from left to right. So I get 16 plus negative 18, which is going to give me negative 2, and then negative 2 plus 21 is 19. All right, let's look at example 4. It says the surface area of a cylinder of radius r, so r is the length of the radius here, and a height of h is the height, is given by the following formula. So the surface area equals 2 pi r squared plus 2 pi r h. They want you to describe in words how the surface area is computed. And I'm not going to write all this down, but basically what they're looking for is you're going to say you square the radius. So we're going to square the radius first, multiply that by 2 and by pi, and whatever that quantity is, we're going to add that to the product of 2 times pi times the radius times the height. And just have to describe that one in words. I think on the homework, probably get one where you might have to write a few words down. Okay, if we look at example 5, it says, and this is another big part of this section, a big part of the homework, it says, in each of the following pairs, the second expression differs from the first by the introduction of parentheses. Explain what difference this makes to the calculation and choose values of the variables that illustrate the difference. So let's take a look at this first one. It says that 2x squared, and then the quantity 2x squared. So the difference is, in this problem right here, the 2 is also affected by the squared. And if we plugged a value in to show, let's say that x is equal to 5, and we're just picking that value randomly. So the first one is 2 times 5 squared. So in this one, we're only squaring 5. So that'll give me 2 times 25, which is 50. In this problem here, the second one, if we replace x with 5, we get 2 times 5. And now because that's in the parentheses, that shifts what you do with the order of operations. So that would be 10 squared, which is 100. So by putting parentheses in this particular problem, it changed the value from 50 to 100. All right, if we take a look at this one, we have 2 times the length plus the width. And then here we have 2 times the quantity length plus width. Or another way they would say that in algebra is 2 times the sum of the length and the width. So if we make the length 10 and the width 5, let's see what we get here. For this first one, we get 2 times 10 plus 5. So 10 is the only one being doubled, which gives us 20 plus 5, which is 25. And in the second one here, we're now doubling the sum of them, which means they're both getting doubled. So that would be 2 times 15, and that would give you 30, which is obviously 5 more than 25, and that makes sense because now the 5 got doubled as well. This is the last part of example 5, example C. So what I want you to do is just pause the video when I tell you to, and we're going to use x is equal to 7 and y is equal to -3. So in a second, I want you to go ahead and do this, show what the difference is, and make sure that you can explain it verbally how putting the parentheses in makes a difference. So go ahead and pause the video right now. You should have had time to work this one out. So if I do this problem right here in red, I'm going to do 3 minus 7 plus. I'm going to put -3 just in parentheses there. That doesn't affect the problem. It's just showing that it's a negative. And I'm going to work left to right. So I get -4 plus -3, which will give me -7 for this problem, the first part. And in the second part, by introducing parentheses, to explain this in words, now you're subtracting the sum of those two numbers. Before, we were just subtracting x and then coming back and adding y. So in this one, if we replaced x with 7 and y with -3, and again, I'll put that in parentheses, that's going to give me 3 minus, and then 7 plus -3 gives me 4, then 3 minus 4 is -1. Example 6 is another one that they just want you to sort of look through, and it says, describe how each expression breaks down into parts. So what they want you to look at, and I'm just going to sort of underline as I go here, it says with this first one, what are the parts here? Well, this is the product of 3 different quantities. The quantities are 1/2, h, and then the sum of a plus b. So those are the 3 parts that it breaks down to. All right. The second one, though, this is really just a big addition problem, whereas this up here was a multiplication of 3 terms. This is the sum of 2 different parts. The first part here is 3 times that quantity, and then 4 times that quantity. Each part of the addition problem here is itself made up of 2 things being multiplied together. In this first part, 3 times x minus y, and then 4 times x plus y. So part C, what you have here is ultimately this is a division problem because it's a fraction, and you have the sum of 2 numbers, r and s, being divided by the product of those same 2 numbers. And again, order of operations, you would go ahead and treat the top and bottom separately, because the division's the last thing you would do. You would get the sum of those 2 terms on top, and then the product of those 2 on the bottom. And the final thing you would do is you would then go ahead and divide to get your final answer. Okay, so now if we look at some real-world examples here, and this book does a great job giving you real-life situations where you'll see comparison of expressions. It says, suppose P and Q represent the price in dollars of 2 brands of an MP3 player. All right? So where P is greater than Q. So of the two prices, we know P is greater than Q. Which expression in each pair is larger? Interpret your answer in terms of prices. So here we have P plus Q.